This triangle represents the calculation we use when thinking about a journey. We can calculate time, speed, or distance if we have 2 out of 3 of the components. We put the formula in a triangle and we have to think about the position of those components when we come to do our calculation. If the components are on the same level, as in speed and time, this is a multiplication function. If those components are on a different level, as in distance and speed, this is a division function. Before we look at calculating, let's think about how we measure each of the individual components. The T stands for time. We measure time in hours, minutes, and seconds. Distance, if we're measuring in metric, we'll measure kilometres. That's for a long distance. We might measure in metres for a much shorter distance. Sometimes we will use an imperial measure, the way that we measure distance on our roads in the UK, and that is in miles. Then the speed element of this is a compound measure. It's the compound of the other two measures. So we might be measuring kilometres per hour or miles per hour. If we have a much shorter distance, we might be measuring metres per second. If we are using the speed kilometres per hour, the units that we need to use in our calculation are kilometres and hours. If a journey doesn't take hours, if the journey is in minutes, but we still want to use those minutes as a fraction of an hour, we simply put the minutes over 60 and use this as a fraction. So for example, if our journey was 45 minutes, 45 over 60 is our fraction of an hour. This will become even more clear when we do our calculations. Here is our first calculation. Now, good practice when we're doing a speed, distance, time calculation is to write out the fact that every journey is going to have a speed, it's going to have a distance, and it's going to have a time. And if we want to calculate anything, we need two of these elements in order to work out the missing one. So, in this question, a van travels 110 miles in 2 hours. So we have the distance of 110 miles. We have the time of 2 hours. And we want to work out the speed. So on our triangle, we're going to cross out the speed because that's the one we don't have. Remember, if our two components are sitting at different levels on our triangle, that is going to be a division sum. So the sum we need to do is distance divided by time. 110 miles divided by 2 hours. We can do this calculation on a calculator, keying in 110 divided by 2, and the answer that would give us is 55. Therefore, what we've worked out here is the missing component of speed is 55, and because we used miles in our distance, it's miles here, and because we used hours, it's miles per hour. Therefore, the answer to our question, what is the average speed of the van? 55 miles per hour. And this mph is the shortening of that miles per hour. Our question here says, Jessie cycles to the library at an average speed of 15 kilometres per hour. She travels for a total of 1.5 hours, and we need to work out the distance Jessie travels. So again, writing out that our journey is going to have a speed, a distance and a time, we can fill in the information that we've been given. And that is a speed of 15 kilometres per hour, and here she travels for a total of 1.5 hours, so that's time. So again, on our speed distance time triangle, we're going to cross out what we don't have, and that's distance, and we're left with the calculation of speed multiplied by the time. So if speed is 15 and time is 1.5, so doing that calculation on the calculator, it's going to look like this. Press the equals and we're given the answer, which when converted to a decimal is 22.5, and we know that 22.5 is 22.5. So either 22.5 or 22.5. It's the same answer. Our distance therefore is 22.5. This was in kilometres per hour, so this must mean our distance is kilometres. The distance Jessie travels is 22.5 kilometres. I said I'd explain how we tackle a calculation where the time is given not in hours but in minutes, and we are expected to work out a speed, as you can see here, that is given in hours. So, looking for the information in the question, a motorcyclist travels for 90 minutes at an average speed of 48 miles per hour. So our time is 90 minutes and our speed is 48 miles per hour. So our calculation is to work out the distance. We need to multiply the speed and the time. But because our speed is in hours and our time is in minutes, and that isn't a constant, we need to change 90 minutes to a fraction of an hour. And we do this by creating a fraction where the denominator is 60, because there are 60 minutes in an hour. So our calculation that we key into our calculator is going to be speed, 48, multiplied by time, 90, over 60. So again, we're going to use the fraction button. So this is what the calculation looks like in the calculator. Press the equals and the answer comes out at 72. Therefore, what we've calculated is the distance here, 72. We look to the speed, and that is miles. Our answer is the motorcyclist travels a total of 72 miles on this journey. Here's a tricky question. A car travels at an average speed of 50 miles per hour. How long will it take the car to travel 12.5 miles? Well, 12.5 miles is our distance. Looking at our triangle, we want to work out time. So the calculation we have is distance divided by speed. The distance, as we've said, is 12.5 miles, which we want to divide by the speed, which is 50. Because that 50 is miles per hour, when we key in the calculation to our calculator and get 0.25, that is 0.25 hours. The question asks for the answer in minutes. So to convert 0.25 from hours to minutes, we multiply by the number of minutes there are in a whole hour. Now, by keying this into the calculator, 0.25 multiplied by 60, we get an answer of 15. We now have the answer in minutes. So 0.25 hours is equal to 15 minutes.